All right, right. Let's see. Easy. Binary number with alternating bits. Given a positive integer, check whether it has alternating bits, namely if two adjacent bits will always have different values. N equals 5, the binary representation is 101, so it's true. 7, 111 is false. 3, it's 1011 is false. Okay, alternating bits. So I can't just do a bit count. I can't do a bit count, right? Let me just do a quick pattern check here. So the valid answers would be 1, 1, 0, which is 2, 1, 0, 1, which is 5, 1, 0, 1, 0, which is 8 plus 2, 10. I assume this is 21. Okay. This is 42. It's going to double plus 1 each time because you are shifting it left 1, which is doubling it, and adding 1, so it'd be 80, 85. Sorry, it's doubling for an even number, doubles and doubles in plus 1 for an odd number, just doubles it because you can't add a 1 to the end. Interesting. So I mean, it's a fixed amount. N is basically 32 bits. N is basically 32 bits. So I pre-compute the set of values that it can be, and then check to see if n is within that set of values. The kind of 32 possible values, it could be 32 being the number of bits, 32 being the number of possible bits. For each possible number of bits, there's going to be a valid solution within that set. So I'll just do, I'll say the valid set is going to be, let's say the current is 1, and then for I in range 32, I guess I'll do the 16. I'm going to do both the even and odd parts within this loop. Let's say current current append, or the valid append current. I guess I should probably make this a set. Valid add the current times equals 2 because it's odd. I could also do shift, but it's fine. Valid append current again, current times equals 2 plus 1. No, that's current equals current times 2 plus 1. Okay, I'll go ahead and just print out the valid set here. Whoops, this would be add. I even did add the first time. Alright, sir. Okay. Seems all good. Seems like the ones that I expected were there. 1, 2, 5, 10, 21, 42, 80, so on and so forth. So here I'll say valid. I think it might have gone too far, like maybe the last one, the biggest one, might not actually be smaller than 2 to the 32, 2 to 31 minus 1. But it's whatever. One more or less is not going to hurt anything. Whoops, I actually didn't want to, what I want to do here is comment this out and then just say valid equals that, and then if n is invalid, or actually I guess I just return whether or not n is invalid. That is the same as the boolean I would return. I wonder if this is faster if it's using a list, to be honest, rather than a set. There's some slight overhead with sets in terms of hashing. I guess it doesn't make a difference. It's all going to be 0 milliseconds. I think. I mean, it's, yeah, it's okay, so general, this is going to be general pattern. So summary, for any number for the valid values for n will depend on the number of bits in its binary representation. So each number of bits has one particular valid n configuration, valid configuration. The pattern, so the total possible valid, the count of possible valid values for n is capped at 32, since n uses at most 32 bits based on the description, based on constraints. 2 to the power of 31 minus 1. Given that, where the problem just needs to verify if n is one of those 32 valid values, using the thus can pre-compute those values in a loop, and then do a check, hash check, if n is in the set. For the loop, for the computation of valid values, note the above kind of general pattern, which is that values will roughly double or double plus 1 from one to the next, which makes sense given the binary kind of nature of binary operations involved. Like when you're shifting over to the left by 1, like 1 0 becomes 1 0, basically this becomes a leading 0, or there's an extra 0 at the end, extra bit at the end, so it's doubling. And if it's an even number, then you double plus one. If it's an odd number, then you're just doubling because you're not adding an extra one to it's already odd, so it already has an ending one before doubling. So yeah, so construct the valid set using a for loop, and then print it out. Take that printed out pre-computed valid set and just verify that n is in that set. Time complexity, this is going to be O of 1 since after pre-computation of valid set, all it does is verify if an element is within the set, which is an O of 1 operation. Space complexity is O of 1 since we're using constant space 32 values set.